All right, still continuing with the gas laws. Today we are going to discuss general gas equation. The general gas equation is derived from two gas laws, the Boyle's law and the Charles law. The Boyle's law states that P1 V1 equals P2 V2, and Charles law states that V1 over T1 equals V2 over T2. Suppose a gas occupies a volume V1. That's the initial volume. At a pressure P1 and absolute temperature at absolute temperature T1. If the pressure changes, new pressure. If the pressure changes to P2 while keeping the temperature constant, T is constant, then using the Boyle's law, we derive the expression for the new volume, Vx. Say the new volume is Vx. We derive the expression from the Boyle's law. So from the Boyle's law, our new volume, Vx, is equal to P1 V1 over P2, where Vs is new volume. Now, similarly, if we change the temperature, remember that initially the temperature is constant. If we change the temperature to T2 using the Charles law, we can derive the value for a new volume if we keep the pressure constant. Change the temperature to T2 at constant pressure. Now we have the Vx, or the new volume. Applying the Charles law, we now have Vx over T1 equals to V2 over T2, such that our Vx is equal to V2 T1 divided by T2. Now, when we combine this equation, say this is equation 3 and this is equation 4. When we combine the Boyle's law with the Charles law, we will generate the general gas equation. So Vx is Vx. So we now say Vx is equal to P1 V1 over P2, which is equivalent to V2 T1 over T2. So from here, the general gas equation is P1 V1 over T1 equal to P2 V2 over T2. If we cross multiply and then we bring down the T's, we have it to be P1 V1 over T1 equals to P2 V2 over T2. And this is what we call general gas equation, derived from both Boyle's law and Charles law. All right, let's take some problems. Our question number 1. A certain mass of a gas occupies 200 cm cube at 20 degrees centigrade and 740 millimeter mercury pressure. Determine the volume of the gas at standard temperature and pressure. STP, standard temperature and pressure. Now, how do we go about this? We have the volume, initial volume, we have the initial temperature, T1, we have the initial pressure, P1. So we are asked to find the final volume, or the volume of that gas at standard temperature and pressure. And we assume that the standard temperature is 273 Kelvin and standard pressure is 760 millimeter mercury, since the pressure here is given in millimeter mercury. So we write down what we're giving here. V1 is 200 cm cube. T1 is 20 plus 273, all in Kelvin, and that will give us 293 Kelvin. And then we have P1 is equal to 740 millimeter mercury. Now, what is our T2? Of course, let's start with V2. V2, we don't know. We're asked to determine V2. Then our T2 is equivalent to our standard temperature, which I said is giving us 273 Kelvin. Then our P2 is our standard pressure, which is 760 millimeter mercury. So applying the general gas equation, we have that P1 V1 over T1 is equal to P2 V2 over T2. So making V2 the subject of the formula, we have P1 V1 T2 divided by P2 T1. So what is our P1 here? Our P1 here is 740, while our V1 is 200, and our T2 is 273, all divided by our P2, which is 760, times our T1, which is 293, and that will give us 181.4 cm cube when you use your calculator. Problem. The second problem says, if the volume of a given mass of a gas at 298 Kelvin and a pressure of 205.2 times 10 raised to power 3 Newton per meter squared. Now you take note that the pressure here is different from the pressure we use there. The pressure here is measured in Newton per meter squared. Pressure can be measured in Newton per meter squared. It can be measured in millimeter mercury. It can also be measured in atmosphere. So we have a pressure of 205.2 times 10 raised to power 3 Newton per Newton meter squared is 2.12 dm cube. What is the volume at standard temperature and pressure? When you see STP is standard temperature and pressure. Given that the standard pressure is 101.3 times 10 raised to power 3 Newton per meter squared, and standard temperature 273 Kelvin. So how do you go about this? Write out what you're given, and from there you look for whatever you are asked to look for. So let's start with V1. Our initial volume V1 is 2.12 dm cube. Now the volume is in dm cube this time around and not in cm cube. Our T1 initial temperature is 298 Kelvin. Our P1 is 205.2 times 10 raised to power 3 Newton per meter squared, while our V2 is unknown. We are asked to determine the V2. T2 is our standard temperature, which is 273 Kelvin. Our P2 is our what? Our standard pressure, which is giving us 101.3 times 10 raised to power 3 Newton per meter squared. Now we apply the general gas equation. P1 V1 over T1 equal to P2 V2 over T2, making our V2 the subject of the formula. V2 is giving us P1 V1 T2, that's we are cross multiplying, divided by P2 T1, and then we apply the figures. So what do we have as our P1? Our P1 is 205.2 times 10 raised to power 3. V1 is 2.12, while our T2 is 273, all divided by our P2, which is 101.3 times 10 raised to power 3 times T1, which is 298. When you apply your calculator, it's going to give you 3.93 dm cube, not cm cube. Remember that our volume is in dm cube. So we return our volume. The unit of our volume here still remains dm cube. Thank you very much.